Hello everyone, my name is Avijit. I am a staff engineer and TLM at Uber. I work on the Kafka team. I also have my colleague Nikin with me. Today we will be sharing our first-hand experiences of operating Kafka at Uber. Right? So let's get started. So at Uber, we have one of the largest deployments of Kafka. And this is the Kafka is one of the key cornerstone of the entire Uber tech stack. It sort of is a backbone of the both real-time and batch systems. Kafka powers several critical use cases at Uber. There are some major key use cases include real-time events which we serve through PubSub systems. We have our monitoring pipeline, observability platform, which sort of is powered by Kafka. We also have analytics platform, which is powered by Flink and Pinot. So Kafka supports that. We have also a lot of CDC logs which are ingested into from our online transaction stores into Kafka. And lastly, it also powers our batch pipeline, which ingests a variety of data into our big data lake, which is powered by Hadoop. So let's start with some basic first. I'm sure a lot of you are already aware. But to get started, let's go into the architecture of Kafka. So what is Kafka? Kafka is a distributed, fault-tolerant, resilient distributed system, which sort of is streaming platform, which sort of lets producers publish messages to Kafka, and consumers can consume those messages. So the Kafka is deployed as a cluster of brokers. When producers produce messages, those messages are stored in topics. A single topic is sort of partitioned into multiple partitions. Those partitions have multiple replicas. With the help of multiple replicas, we are able to have redundancy. So if some replicas goes down, you still able to, the topic is still available for read and write. So within a partition, the messages are stored as log. You sort of queue the messages inside one log, and the smallest unit of a log is a message, right? So for every partition, there will be multiple replicas. One of the replicas will serve as a leader, and other replicas serve as the followers. The leader is responsible for any publish or consumption request, and the followers sort of keep up to date with the leader. If the leader, for whatever reason, dies, one of the followers can become the leader, and it can take over the ownership of that serving those requests from the consumer, right, or the clients rather, right? So as long as for a topic, you can so the number of replicas which are in sync, which are called in sync replicas. If the number of live in sync replicas do not go below certain threshold, the partition is sort of available for read and write. So this is how briefly what Kafka is. We'll jump into the problem statement. What is the problem we are sort of trying to solve? So at Uber, we are recently were tasked with one of very critical problems. This is about hardware upgrades. So our previous hardware had been running in production for quite a long time, and over the time the disks had got deteriorated, which caused frequent disk failures. So when the disk fails, the host also fails, and it sort of it can affect the availability and reliability of the cluster. So when a host fails, we have to sort of bring back a new host which has all the previous data of the failed host. We sort of build this data on the new, so we have to bring up a new broker which has the same data as existing one. We have to sort of bootstrap that new broker. Once it has all the data from the previous one, we sort of bring it as part of the cluster. So this process is called offline rebuild. So like so like this offline rebuild sort of takes a lot of time. In our production clusters, used to take about 8 hours of time to replace a failed broker. So during this time, if another broker fails, we sort of on the risk of data loss, because if multiple replicas go down and the number of in-sync replicas go below the under min ISR configured for that topic, you will not be able to produce or consume for that partition, right? So because our old hardware was sort of having these issues and it was causing frequent like host failures, we wanted to bring in a new hardware which is more performant, so the ability and reliability of the cluster can be guaranteed at a higher threshold. So this is okay. So what are the challenges we sort of faced during this upgrade process? So at Uber, we have thousands of brokers across clusters, and all of these brokers had to be replaced with the new hardware, right? It is a massive scale, and to finish it in a reasonable amount of time requires a lot of effort. So to give an insight, what is the way to sort of bring in the new hardware? So what we can do is we can bring down an existing broker in the cluster, and during the offline rebuild process, we can pick the broker from the new hardware, and we sort of bootstrap this new broker which is running on the new hardware with the old data, right? This is one way to do it. So we are sort of replacing one host in the existing cluster at a time. But a single replacement, as I said, it takes a lot of time. In our production clusters, it used to take about 8 hours to complete. So to imagine a cluster which is 150 nodes, it would take 50 days to finish. And for us, the number of clusters which we have, it was not possible to sort of finish it in less than a year. So that is sort of a very long size. We wanted to sort of see what we can do to minimize the amount of time to complete this upgrade. Another thing is approach could be to instead of replacing one host at a time, you could say why not replace multiple hosts at a time, right? But that brings in the same problem. If two hosts are down, you are at the risk of another node broker going down all by itself, and then it will cause data loss for you, because if the number of in-sync replicas sort of drop below the threshold, those partitions will become unavailable, right? And the last of the challenge was the previous hardware was more like a meaty machine. It has bigger disks, but the new hardware which we're trying to adopt, that came with only 1/3 the disk capacity as the old host, right? So it sort of becomes a problem because you cannot do a one-to-one replacement. Yes, you simply do not have enough disk capacity on the new hardware to hold the same amount of data which the previous host was able to hold, right? So as I said, the new brokers, they only come with 1/3 the disk capacity. You can only sort of replace using a one-to-one strategy if the previous broker had like less than 20% disk usage, because as soon as you replace it one to one, the capacity would go above 60%, and then will not be left enough room for any organic growth on that broker, right? Other thing we could do is like if we could bring down the disk usage to less than 20%, we could do that by reducing the total retention for our topics. So we could reduce it to 1/3. It could make it below 20%, but like that also that impacts our customers, and like they will sort of have lesser time window or retention to work with in their application. So that is something which was not an option for us. The other strategy could be like for every broker you replace, you can have 3 brokers added to the cluster. Though it sounds simple, like it creates other set of challenges. Like imagine like 150 node cluster would become, if you replace using 1:3 strategy, the cluster would become 450. I don't think nobody has tried. Like normally we don't want to have like such large clusters. It can affect, it can make the operation really challenging. For example, if you have to do any deployment for any hotfix or something, the deployment time will become 3 times, right? And also like you will have bigger clusters, so you will also need to spend a lot of money for your clusters. So yeah, these are the set of challenges. We sort of like for both the strategies, we are the problem still is there. Like how do you sort of replace the old brokers with the new ones? So what is the solution to that? So for this, to solve this problem, we sort of adopted tier storage. This tier storage is a feature which was built at Uber to sort of like reduce the disk requirements on the local brokers. So what is tier storage as a feature? So as you know, like only like in normal applications will only try to consume the latest data more often, right? Like it's like a pub sub sort of system. Like you're always like your applications are mostly caught up. You only try to read more recent data, but like normally the retention for your topics may be 2 days or above, but all of the data is not accessed very frequently. Like maybe beyond a few hours, you may not be accessing it very often. So what tier storage allows you to do is you can offload older data to a cheaper storage, which could be like on a remote, for example, HDFS or S3, right? You can offload them to a cheaper storage, which is not, and outside the brokers. With the help of this, you are able to reduce the local disk requirement, right? That data, it can still be accessed whenever required, although it will be slightly slower than what throughputs you can get from local. But those use cases are rare, like as in like you won't need that data very often. So it's like a sort of trade-off, and like for most system it does work. So we sort of like this feature, like I said, was built at Uber primarily for this purpose. And what we did was we were able to bring down we could not reduce the total retention, but what we can do is we can specify a local retention for topics, which can be a few hours. The total retention can still remain the same, but that data is moved to HDFS or remote storage. But like what will this do is like on the local disk you need lesser capacity. So with this we can if we bring down we set the local retention as 1/3 of the total retention, the disk requirement goes down to 1/3, and then it unblocks 1:1 replacement from old broker to the new broker, which has lower capacity. What this also does is like the replacement time sort of comes down by 80%. Previously, when you used to take because you have to rebuild that entire data the previous host has, because you're dealing with lesser amount of data, you only need to copy the data which is on the local broker. You don't need to copy anything which is on the remote. So the amount of data is also getting reduced. Hence, the time to replace that host also gets reduced. So in our environments, it came down by 80%. Previously, it used to take around 8 hours to replace, and now it takes less than 2 hours to replace a faulty broker. So this works well and good. Like, what we can do is we can iteratively go over each broker in the cluster and replace them one by one, and we should be able to achieve the entire upgrade in a reasonable amount of time. Overall, it should come down by 80%, right? Instead of overall where it used to take taking like almost a year, it can be completed in a few months. There are scenarios where like one-to-one replacement is still difficult. This may happen because your cluster is already very big in size, and the disk usage is already is so high that even if you set the local retention as smaller value, it would still exceed that 20% mark, and then you sort of it becomes difficult to replace using one-to-one strategy. So what do we do in such scenarios? So in this, for such cases, like we used rebalancing the cluster to achieve the replacement. So or rather, like we move the data out of the old brokers to the new brokers using rebalance, and we sort of decommission the old brokers. In this way, we are able to sort of decommission or get rid of the old brokers from the old SKUs. So I will hand it over to my colleague now to take it forward from here. Yeah, please.
Thank you, Abhijit. My name is Nikin. Good afternoon, everyone, and I have a question for you. So how many of you have changed your phone recently or once in a lifetime at least? Almost everyone, right? So this means that, okay, you have also, had this problem and you have solved on your own. And that's the same strategy that we are going to use it right now. So when you're changing the phone, how many of you had this hassle of porting the data from the old phone to the new phone? Right, almost everyone, especially when you change your phone from Android to iPhone, the headache is more, right? So this is what we faced. We have to change our hardwares, okay, completely of a different characteristics, and how did we pull it off? So one thing is that if you had changed the phone, you would also had a backup in your Google Drive or iCloud. Is that true? So that is what we also did with the remote storage. So we would actually copy all the data from the local disk to the remote storage, okay, like a HDFS, where the cost is low, and then we just want to copy the data that is just there in the local storage to the new SKUs, right? So for this, we are going to use a process called rebalance. Rebalance is a common process that we use in everyday activity for Kafka clusters. For example, when there are 100 nodes in the cluster, a few of the nodes, the disk usage is really high, and we don't want to run into the risk of getting the machines go down because of the out of memory issues. So what we do is that we move a certain part of data, certain amount of data from the brokers which are heavily loaded to the brokers which are sparsely loaded. So we are going to use this technique to move the data from the old hardware to the new hardware, and then we decommission the old hardware, right? So what is the rebalance? It's a process of assigning the partitions from the one set of brokers to another set. Right now, so yes, this is the process of rebalance. We want to just say this yellow follower is the old SKU. It's just the old hardware we want to replace. From the leader, we add another follower, which is the new SKU or the new hardware, and then we start replicating the data from the leader. Once it has completed the replication from the leader, it becomes the in-sync replica, which means the follower has all the necessary data from the leader, in which case if a leader goes down, the follower can become the leader. So when the in-sync replica is added, we are going to decommission the old follower. So yeah, So yeah, it's a repetition of what I said before. We are going to identify the old hardwares, just add the new hardwares to this cluster, and then we just calculate how much new hardware is required depending on the size of the data that we are going to move. And then we are going to rebalance all the partitions, and then once the partitions are rebalanced, we are going to decommission the old nodes. So let's take an example, pictorial example here. So imagine a cluster with 100 brokers, and we have decided we are going to decommission broker 1, 2, and 3. So there are the partitions and topic partitions residing in these brokers, and let's consider that every partition has 3 replicas. We have replicas, nothing but the copies of the partition, because if the node goes down having the hosting that partition, we would want another replica to become the leader and start serving the request, right? So this topic 1, partition 1 is having 3 replicas, and out of these 3 replicas, we have decided that we are going to knock off the broker 1. So what we have to do is that we are going to expand the replica set for that partition. So the broker number 103 is the new hardware, and then we are going to add that partition to the broker. Now after the sync completes, when the 103 broker becomes an in-sync replica, the expansion phase is over, and then we go on to the shrinking phase, wherein we're going to remove the partition from the broker 1. So the new topic partition replicas are 15, 47, and 103, wherein the broker 1 doesn't have any partition left. So in which case, we can safely remove the hardware or the node from the cluster. So what are the challenges? As Abhijit mentioned, right, the rebalance process is very slow. It takes about a day to decommission 10 nodes. And when there are hundreds of nodes in the cluster, and there are many clusters of that sort, the timeline is shooting up beyond a year. And how do we achieve it in a faster time and more reliable manner? Because when it takes a lot of time to do this rebalance, we are also having a problem of having the old hardware sitting inside and serving the data, and which are highly prone to the hardware failures. So there must be a better way. So for this, we need to understand how the remote storage works. So for example, let's take the analogy of your photo gallery, which you are syncing into the iCloud or the Google Drive. This is your phone, and this is your photos that you have. Let's say this, you have some 100 photos that you have taken this year, but you can go to your Google Drive and see the photos which you took last to last year, which is not even in your phone. That is this remote storage for you, right? So this remote storage will also have a backup of what is in your phone gallery, which is in the local, and also which is not in your local. So for example, in the Kafka terms, consider this as the total retention. Total retention is the local retention plus what data you have in remote as well, right? So let's say there is block 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If a consumer asks for the any offset in the 9th segment, we go to the remote, copy the data and serve it to the customer. But if they ask for any data in the segment 3, we just give it from the local. So the difference is here from the local, the latency is less, the latency is high in the remote storage. But what is the trade-off? Here the cost is high, the cost is low there, right? So now during the rebalance, when you're going to add a replica, what we have to do is that, let's say we're bringing in this follower, we have to copy all the data from the leader to the follower, so that when the leader goes down, this follower can take up the leadership, and then it can start serving the data to its consumers, right? So it has to copy all these segments, and then this will be good to go as an in-sync follower. But this is the problem where we need to copy a lot of data. For example, there are terabytes, if not petabytes of data to be copied, right? So what is the improvement that we can have over this? If you see, when we need a data from the segment 9, we go to the remote and we fetch it and service are consumers, right? So similarly, imagine that there are only 2 segments here, right? And then this becomes the leader. And if any request comes for the 3rd segment, this follower can still go to the remote and fetch the 3rd segment from there, isn't it? So we don't wait for the local retention to expire to be for the segments to be pushed to remote, rather than we proactively push the data to remote. So when a new follower is added, it can only copy the data that is not there in the remote. So in which case, the data that needs to be copied has reduced by 85%, and then only the last 2 segments are, depending on the lag. If there is no lag, just that active segment is just need to be copied. And that is what we call it as a reassign method, tiered storage strategy, tiered offset strategy. So the tiered offset is what we discussed. It is the offset of the segments of the data until which the data is already there in the remote, after which the data is only in the local storage, right? Since we proactively push the data to remote, this data after the tiered offset to the local end offset is very minimal, and then to add a replica, we just need to copy this data only. So with this strategy, we are able to reduce the rebalance time by 85%. To give a timeline, without the tier storage, when there was no Google Cloud, right? You have to manually copy all the data to the new phone. Similarly, it took more than 16 hours for one rebalance to take place per node. But with the tiered strategy, let's say with the Google Cloud, we just need to copy our local data, like all the 100 photos that happened. With the tiered offset strategy, that let's say you are pushing your phone photos to the cloud only if your phone is going out of memory, right? But if you proactively push the data to cloud, but you keep all the photos in sync, then you just need to copy the last photos that is not synced to the Google Cloud. That is what we call it as tiered offset strategy. With that, we were able to rebalance less than 5 hours, like around 1 to 2 hours for the entire node. So with the remote storage and then with the tiered offset strategy, we were able to decrease the rebalance time and update to the new hardwares with 85% of the time saved. And we also automated this process for all the clusters on the nodes so that there is no manual intervention and then no room for human errors. And it also worked round the clock, and we were able to achieve in a much faster time. Thank you.
Thank you so much for amazing presentation. I have a microphone, so I see already raised hand so quick.
Yeah, hi, this is Damodar from IG Groups. So I have a question. Before I ask my question, your Kafka clusters are deployed in physical machines, VMs or cloud?
Physical machines.
Okay. So in that case, why you guys haven't considered to deploy on VMs to avoid all this hectic work?
Yeah, I mean, I think that is sort of strategic. Yeah.
Because I wanted to mention, because from my perspective, what I felt was, rather than Kafka, it's more infrastructure constraint. That's what I felt. Because if you would have used VMs, you could avoid doing all this work, and I think in 20 minutes, half an hour, you can copy the node, whatever you want to change things.
But if the hardware configuration is different, right, then you would not be able to do it. And you want for having very low latency for serving at Uber scale, right? You want to be reliant on, you have to select such hardwares that can give out this low latency. And for any new hardware to be added into the cluster, we have to do a lot of benchmarks. So if there's a VM and if we think that, okay, any physical machine can be put and then we can run the Kafka node on it, it may not be possible. Yeah, so that is the reason we can't do it.
Because when you say latency, again, you're copying to remote, right? So you're missing there.
So as my colleague Abhijit mentioned, most of the Kafka consumers are served from the local storage itself. So that's why we have a local retention. For example, consider we have 1 day of data in the local and then rest of it in remote. And most of the Kafka consumer, they don't want to process in lag since we are talking about low latency, right? So they're always almost caught up. If there is any backfills, if there are any failures, that's when we touch the remote storage. So that's why we are good here.
Thank you. What's the latency that you've seen when the data that you said the retention is reduced, right, in the local copy, and you put it onto a tight storage, and if the consumer is not able to catch up with the producer, you've got millions of records still consumer still lagging behind. So what is the latency that you see when it's kind of pulling from the tiered storage?
Yeah, it depends on on your whatever remote storage configuration. For us, I think maybe around a factor of 2 is what we get, but it's factor of 2. So the throughputs which we get from local maybe around factor of 2 is nearly like less than 2x is what we get, and that sort of works for our clients because it is like a rare scenario where we backfill. So,
but
yeah.
I mean, so you're kind of now reducing the whole capacity of data streaming, right? The whole idea of data streaming is that you have the data immediately in your systems where you can start processing it. For example, data analytics, which needs real-time data. If you're in a fintech technology, right? So you need data immediately to do that.
So it is only for the data which is not there. So like normally our local retention is high enough that you don't need to, like, we sort of track what is the percentage of requests for which we remote data was required. We sort of make sure that like 99% or whatever is already there in the local. Only certain like maybe more than several hours is what we store in remote storage. Otherwise, always there in the local storage for most of the applications to work, right? And it is also depends on the workload. Like for some workloads, the data is not, they can sustain some latency, like maybe they're batch applications. For them, we can sort of have lower retention on the local. In some of critical use cases, we don't even use this. We all have all the data always locally. So yeah, it continues to be as is. Yeah.
Okay, because the reason why I ask this is we take price ticks from different sources, like at 1 billion ticks per second. Mm-hmm. So the data is too huge and too voluminous. So we need to stream it to the analytics tool so that they can kind of see the pricing data very quickly and tap into the customers where we can see where they really are trading on. So now when you're moving retention to a tied storage, so now the latency is very high.
Yeah, but like I said, like from remote storage, we like serve maybe less than 1% of the total requests. Yeah. So we have configured it such that you would not almost need that data all the time.
Okay.
Yeah.
Thank you.
To explain with this picture, right? So we are proactively moving all the data to remote, but we still have it in the local. And if there is a data in this segment or fourth segment, we don't go to the remote. If it is already present in the local, we serve it from the local. So we still have the low latencies.
Yeah, it might be a repeated question, but if I'm not wrong, Uber is now currently moving to cloud, phase-wise for different services. If this particular service moves on to the cloud, wouldn't that actually solve the initial problem of when you want to upgrade your hardware, you can just take the particular block storage and attach it to some other compute machine without doing any such changes?
So like we are not like going via that route that you sort of attach as a block storage. It is still like a single machine which has local disk. So
right.
Yeah, that is a different XI which is going on in open source.
But currently, this is on-prem, right?
We are partly on cloud as well. Yeah.
Partly, okay. So even if you were to move on to cloud, you would face the similar issue with the similar challenges.
Yes. Yeah.
How frequently do you upgrade AK?
I think like maybe once in 2 to 3 years. Yeah.
Okay, currently you are on which version?
I think that version you're saying?
Yeah.
So like we are currently on like forked version of 2.8.
Okay, 2.8.
Yeah.
And one more question. So when you do a add broker and remove broker parallelly as part of rebalance, so how many brokers do you add parallelly and work on removing parallelly? Is it like one broker at a time, or you do some
so
chunks of 10?
When you're doing a rebalance, typically you want to have more parallelism. So you could choose something like maybe 10 to 15 at a time, right? You decommission 10 to 15 at a time and add the required number of new brokers. Yeah.
It also based on your strategy. For example, if your system is fault tolerant, if one zone can still withstand the failure of another zone, we can consider moving the brokers from one zone. Upgrading the brokers in one zone without touching the brokers in the other zone. So that way you can group your rebalance assignments.
Okay, thank you.
Yeah, hello. So can you go back to the screen where you showed a red broker and a green broker? The next one. At this point, if a new topic is created with, let's say, 6 partition, the partition would go to the red broker also, right?
No, so we have a feature which sort of says new replica exclude list. I cannot remember if it is present in open source, but what this does is like it will prevent any new replicas from going into the brokers which are specified in that list. So before we start this process, we put these red brokers into that list so that no new replicas can be created there.
That's a Kafka feature?
I think it is an internally developed feature, yeah.
Internally developed, right?
Yeah.
So we often do this and we run into this problem.
Okay, yeah, okay.
Thank you.
Question. So, what tool do you use for rebalance? Is it like some open source tool, or you have like a script that you use to do the rebalance?
So it uses internally the rebalance reassign partitions tool itself, but we have like a custom sort of a tool which sort of is a wrapper over that one, and it can like it provides a lot of configure like options for us to like say which is a source, which is a target. So it's a wrapper which gives more options for you to do. That is what we use right now. We are sort of in the process of migrating to like using cruise control.
Yeah, actually we are using cruise control, so
okay.
It's a lot more smoother that way. Because earlier we used to use some script to do the reassignment, and it was very time consuming process. And so on the similar note, I wanted to ask that if because you are using wrapper, that's why you are doing one node to one node migration, right?
No, you can specify like a batch. Like I said, you can say these are my source brokers, this is my target brokers. So it can be more than one. Typically you want to do in a batch because it will give you more parallelism at a time, right? You want to copy from multiple nodes here.
Okay, so basically let's say if you have one Kafka cluster which has 20 brokers, and you want to move it to a new hardware. So basically you will create 20 new brokers with the new hardware type, and then you will trigger a rebalance, so which will move all the partition from old broker to the new broker.
Right.
So you will do it one at a time, or you will do all at a time? And if
typically you don't want to do like for the entire cluster at a time, like we sort of identify batches for that cluster and break it, like do it in batches. That's what we do.
Okay, so I mean, why you don't want to do it all at a time? Because reassignment plan will contains all the information, like this partition you want to move it to this broker, so
correct.
It will have all the data.
So all the leaders will sort of like, if you are sort of doing from all, like choose all the 20 brokers at a time, right? Like all of them will be leader to some partitions, right? And you're moving the entire data to a new one, right? So suppose your replication factor is 3, now suddenly it becomes 6, right? It will put like a lot of load on the leaders, and it can sort of deteriorate its performance, right? Because it has more data to more followers which are trying to catch up, almost double now. In fact, double the number of followers now. So we don't want to do it at the same time. We sort of want to keep the load on the leaders minimal, so your production is sort of not compromised.
Okay, sure. Thank you.
Hi, this is Syed. So when we are asked to migrate to new hardware, okay, instead of doing partition reassignment, did we try to stop the broker 1, and on broker the box number 101, did we try to give broker ID 1 again and start it, so that it will sync the data from the replicas which are available on existing cluster?
The whole problem statement was based on there was no 1:1 replacement. The old broker that we had massive local storage, and the new performant brokers that we wanted to bring it in, they did not have as much as local storage that the old broker had. So what we had to do is distribute the data to the new brokers. So that's why 1:1 replacement was not possible.
Any specific reason you don't have disk on new brokers? I mean, new boxes? I mean, new hardware, you should get enough disk, right?
No, I think that is the trend in the industry, that like you want to have lesser amount of local disk.
I mean, you want to implement tier storage?
No, not. I think that is not even this.
So when you're saying it's a trend to have lesser disk, quite contrary, day by day we are getting more data. We are seeing terabyte, petabyte, right?
Yeah.
So I found that contrary.
So like we want to, like, it is a trend to sort of decouple storage from processing. You want to have machines which are more optimized for processing. You want to have machines which are more optimized for storage. That's why you sort of have, like, that is a trend that you provide lower disks with machines which come with more.
No, the more important reason being the cost itself, right? Why do you want to have such a large machine with SSD disks when you can just live with rotating disk, right?
Yeah. Just little off topic. Why haven't you guys considered Confluent Cloud in that case? Fully managed, right? It will take care of everything. You don't have to bother about anything.
Again, it can also be answered in terms of cost, right? And then as the previous speaker also mentioned, when they want to deal with much lower latency, they want to have the full control. At Uber scale, right, we want to have full control of what's happening, and so we want to have fault-tolerant system that is in our hands, and if there are any outages, our developers are able to jump in and quickly fix the issues. So there is no black box.
Yeah, thank you.
Hi, is this like duplication consumption is a concern here? Like if you move from old SKUs to new SKUs, the offsets preserves there. How do you handle that? And the alternative of that is like, have you considered of using like mirror maker or things for similar migrations?
So this reassignment is like a regular exercise for Kafka. It takes care of those offset management. Mirror maker is more for like you want to replicate data from one cluster to the other cluster. So it's a slightly different use case than like putting new brokers in an existing cluster and replicating at a partition level. So it's slightly different in that way.
So even in normal scenarios, your data is always growing, right? And you want to add new brokers and then shift some of the partitions so that the existing brokers are not overly loaded, right? So it's a common operation that the rebalance is being done for the Kafka clusters. And the Kafka protocol takes care of the offset management.
Yeah, I think you have explained rebalance from a migration POV, but we generally want to increase partitions for Kafka. Like let's say we are pre-scaling for a peak or something. So generally rebalance needs to be coupled with increasing partitions, repartitioning basically. So any challenges you faced during rebalancing plus repartitioning. So how do you position them? Like do you repartition the cluster first and then do the rebalancing, or you rebalance the existing partitions and then do the repartitioning?
So I am not sure I got the question, but like, are you saying when we are planning for peak capacity, you sort of also increase the number of partitions?
Yeah.
I think that is a parallel exercise which keeps happening all the time. If we see that the partition is nearing sort of the recommended highest throughput, we sort of trigger like repartitioning by itself. So that is a parallel exercise we do anyways.
Yeah, that is basically to increase the throughput on the consumer side. But when the producer wants to publish more records, let's say consumers is not the bottleneck. So we have to pre-scale and basically we have to increase the partition. We are expecting data in future.
Right. So even for like if you don't want to put too much data on from the produce side as well, because the consumer also needs to catch up with that data in a reasonable amount of time, right? So typically you don't want to exceed certain throughput per partition. So that is when we sort of follow a guideline that we'll not go up this. If it goes beyond that, we sort of ask our topic owners to sort of increase the number of partitions.
Okay, got it. So you frequently use this rebalance in those cases?
Yeah, so I think it depends, like if you have keyed messages or not. Like if you are not, like anyways, new messages will automatically be assigned to new partitions if you're not using keyed messages. Yeah.
Got it.
Yeah.
Okay. Hello. Hello.
Yeah.
Yes, sir. If my understanding is correct, so this rebalancing technique is completely built by the Uber only. Like Apache Kafka don't give this rebalancing property like you have explained. If I have 10 partitions with 2 brokers, it will get shared by 5 in 1 and 5 in 1. If I add one new broker, it will get 3 or 4 partition in each broker, right? But as per your rebalancing, you are copying the data of one partitioning from one broker to completely a new broker. So is that rebalancing was developed by your company?
So the underlying tool which the wrapper uses, they're called reassign partition script. It is there for everybody to use. It is like you will need when you are managing your clusters. What a wrapper does is like it gives you more options to like how you can use that script, that reassign partition script. That is our rebalance script, which sort of tells you, okay, you can give these source broker, these target brokers, and you can move just between these, or you want to do the entire cluster rebalance also you can do. So it lets you generate the plan and execute it as well. Yeah.
Okay, and one more question I have. When you said key less used data is migrated to the remote SDFS type of storage, so how do you, what we say, how do you recognize which is less used data? Like in Kafka, we have offsets, that earliest offset or latest offsets. So how do you recognize which is the, like we have the retention time of only 10 minutes where GB per second of data comes in the picture.
So right, so like when we sort of have an internal metric which sort of tracks what was the
consumed offsets
timestamp versus what the current timestamp is. What's the like sort of time difference? So we sort of have that metric. We sort of emit it for all our topics, and we know like what is like maximum you would normally sort
so
of
that's
access.
your application that maintain that metric. So
yeah,
that
so
must
in
be
our,
very fast as well, right?
So in our internal Kafka, we sort of have that metric which tracks the usage pattern. Yeah.
Okay. Thank you.
Thank you for all the questions, and I think we're running out of time. However, you can find our speakers after the talk also, and I guess you will be welcoming more questions after. Thank you, everyone. Another round of huge applause.
Thank you.
And I'll see you for the next session.